Hi there, and welcome back to the Snowflake Developers YouTube channel. My name is Caleb Baechtold, and I'm a principal architect for AI and machine learning here at Snowflake. Today, I'm going to walk you through a demo of how to use SnowparkML to build end-to-end machine learning pipelines, all natively in the Snowsight user interface using Snowflake's brand new notebook capabilities. Let's just dive right in. Okay, so the demo that I'm going to walk you through today is based on our Intro to Machine Learning with SnowparkML Quick Start, which you can access today via quickstarts.snowflake.com. It's kind of our standard walkthrough for doing data preprocessing, building a preprocessing pipeline, training a machine learning model, deploying that model for inference, a typical sort of start to finish ML workflow, all using the SnowparkML APIs for that preprocessing, your model training, and using Snowpark Model Registry to ultimately register and deploy the model. So the code we're going to be doing today in Snowflake Notebooks is based on this quick start. And the GitHub repo for this quick start has a Snowflake Notebooks now directory, which has our native Snowflake Notebook version of .ipynb files that have all the necessary changes from the original quick start so that they can run inside of Snowflake Notebooks. The changes are minimal. I'll kind of point them out when we get into the code here. And in fact, they actually just make your life easier in terms of the code you have to write to get started using SnowparkML and notebooks compared to in VS Code or Jupyter or something like that. So you want to go ahead and clone down this repo to your local machine because we're going to ultimately create notebooks from these .ipynb files. Once you have that, I'm going to go ahead and log into Snowflake, which brings me to the worksheets page of the Snowsight user interface. This is most people's landing page. You could land on the search or something like that, but you'll probably end up on the worksheets page. And you'll notice over here on the left-hand side under the projects menu header here, there is now a notebooks option between worksheets and Streamlit. And that notebooks is going to be exactly where all of our notebooks live within for our user that our user and role have access to. You notice when I click on it here, that one, we see the preview tag because as I mentioned before, Snowflake Notebooks are currently, at the time of recording this, in preview. But you'll notice there's no notebooks listed simply because I haven't uploaded any notebooks in this account yet. On the right-hand side, you'll see the search, which if I had notebooks, it would allow me to search through all the notebooks in my account so I could see where they are, find them easily. And then there's the plus notebook button. When you click the plus notebook button, that basically brings up a new create notebook wizard, which will ask you to name the notebook, specify the location. So like most things in Snowflake, the notebook has to live inside of a database and schema, as well as the warehouse that we want the notebook to use when we actually run our code. Since I already have those .ipynb files, though, I actually don't want to create a new notebook from scratch. Instead, what I'm going to do is click the arrow drop down here and select import .ipynb file. I'm just going to open up my file explorer here. And inside of that Snowflake Notebooks, I have my first notebook, which is going to be our data ingest notebook, which we'll start with. So I select that in my file explorer and click open. And it's going to ask me again to verify the name. It's just going to use the file name to start with. It's going to ask for the notebook location, which in our case, we want to use just this MLHOL-DB and MLHOL schema. That's the same database and schema that the original Intro to ML with SnowparkML uses. And then it's going to ask us to select a warehouse, and I'm just going to select our MLHOL warehouse. You could select a different warehouse, of course, different notebook location if you would like. But these are kind of the easiest way to get started for this code. And then I click create. That is going to create the notebook. And then once it's created, it's going to take me to the actual notebook editor itself. And you can see some initial code cells are starting to pop up. We have some markdown here that's rendering as it gets started. Cool. And we have our first notebook based on our ipynb file. Okay, so let's orient ourselves a little bit to the notebook environment here. So kind of starting from left to right. Over on the left, we have all of our menu shortcuts, which will take us back to our projects or data activity pages inside of Snowsight. We've got our back button, which will take us back to the notebooks homepage. We have our notebook name and a drop down here, which allows us if we wanted to rename the notebook or change the default settings for the notebook or anything like that. We can do that there. Below that, we have our typical Object Explorer, which you're probably accustomed to seeing if you use Snowsight before, even worksheets, or even things like the VS Code Snowflake extension. So these are all the database objects that we have, our current role has access to and all that, which you can click into and explore a little bit to see, what data, what tables and functions and stages and things like that exist within each of those databases and schemas. Then in the middle here, we have our actual notebook cells themselves. So you can see here at the top, we've got a few markdown cells, then some Python code, and we'll walk through all of this in more detail as we get into it here. Along the top, then we have a few more things. So we have our package picker, which if you've used, Python worksheets or anything like that, you've probably seen before. This allows us to specify certain packages that we want installed into our, alongside of our notebook. We'll take a look at that in just a minute more as we get going writing some code here. And then we have our start button, which essentially means connect my notebook to the warehouse, start a session so that I can start executing code within my notebook. You have your typical run all button along with the keyboard shortcuts for doing that, and a drop-down menu where you can do some duplicate, export, delete, typical management stuff. The other thing we have on the right-hand side here is kind of like a mini map to the cells within our notebook. And you see here, in this case, they're just saying like cell 1, 2, 3, 4, 5 as they go along the way. And as I scroll through, you can see that I can actually see different parts of the cell that I'm viewing. If I click on a cell, I can see which one I've selected. So you can name your cells, which gives you a really handy way of then navigating along the right-hand side. If you have a pretty long notebook or something like that, you want to jump to a specific point in the notebook, you can use the mini map and things like that to do that. So that kind of gets us oriented to the notebook. Now let's start looking at actually writing some code. All right, so to start writing some code, the first thing we're going to need to do is select packages that we need for the particular code that we're going to be writing. We can do that via the package picker up here in the top right. If I select that, you'll notice that there are a number of packages already pre-installed. So obviously we have Python in here. We have a version of Snowpark API installed, Streamlit, some other things that the notebook needs to run itself. But for us, because we're going to be doing some ML work, I also am going to need the Snowflake ML Python package, which I can search for and then select. And you'll notice then that the package is selected here. It allows me to choose different versions if I want. I'm just going to keep using the latest one. And that's the only package I need for now. So to do now, basically, I need to connect my notebook to the warehouse so I can start running my code. To do that, I just hit start. And you'll see that that'll spin up the starting dialog here. And as I scroll down through to start looking at my code, I can still see, obviously, my menu options along the top. So let's go ahead and start talking a little bit about the code that we're going to write. Now you'll see that our notebook is active here and on the particular warehouse that it's running on. So this quick start goes through the classic kind of diamonds data set, which is used all over the place for data science and machine learning tutorials. Basically, you use diamond features to predict the cost or price of the associated diamond. So we're going to go through kind of the typical pre-processing steps to do that. I'm going to go ahead and hide our sidebar over here just to make things a little bigger. And the first thing, like all notebooks or Python code, we're going to need to import some specific libraries that we're going to need. And you'll notice here when I click on a particular cell, there's a number of different options. One, I can select the language of the cell. So Snowflake Notebooks, you can use Python, SQL, or Markdown all in the same notebook. And importantly, SQL and Python cells can interoperate with each other. So the output of your SQL can be a Snowpark data frame that then is passed to some Python code or whatever it might be. There's the cell name, which I mentioned before, gives you the minimap kind of location. And then we have the run this cell only, collapse cell, and then some other options for run cell in advance, run above, run below, move, delete, all that kind of stuff. We also have the typical keyboard shortcuts of like Command Enter on a Mac to run a cell. So there I just ran that to do our imports here, just like I normally would from a Jupyter Notebook or anywhere else. Now, the next thing we need to do is create our Snowflake session or get our Snowpark session. Now, if you've used Snowpark from VS Code, Jupyter Notebook, anything like that, to do that, you have to supply your credentials and all that sort of stuff. With Snowflake Notebooks, there's an active session as soon as I click the start button up here on the top right. And to get that session object and then write corresponding code using it, we just have this little helper function called getActiveSession. So all this stuff about connection JSON and things like that you might have previously needed, we don't need that anymore in Snowflake Notebooks. So what I'm going to do is I'm going to get active session, and then I'm just going to print out a bunch of information about my current user, the role, the warehouse, the Snowpark Python version that I'm using, all that sort of stuff. So you can see here my Caleb user is connected. I'm using my sysadmin role in a particular database schema warehouse, all this different stuff. And all I had to do there was just use this getActiveSession helper function, which is provided in the notebook directly and allows me to start using Snowpark. All right, so in this typical flow, then the next things we'll need to do is also read some data in. In the case of the diamonds data set, we actually have that staged in an external stage from an external S3 bucket, and we can use Snowpark to read that in using schema inference and all sorts of other stuff. The same way we would if we were running this anywhere outside of a Snowflake notebook. Let's go ahead and run that cell, and you'll see here the file listed from that external stage diamonds assets, the size of it when it was last modified. We then read that data frame in from that CSV file, do a quick preview on it, and then look at some summary statistics about some of the different fields in the data set. Easy peasy. And you notice that those .shows, .describes, etc. are rendering the output from those Snowpark commands just like they would if you were running them in, again, any other sort of notebook environment. Can then do things like look at the columns associated with the data set, print those out. And then we need to do some basic data cleaning. So things like forcing the headers to uppercase or doing some manipulation, some formatting for a particular field in the data. I'm going to just kick this off and just have it run all the cells below so as we walk through. So here we're just doing some basic renaming of one of our columns, and then doing some standardization on cut so that we can get rid of, any unnecessary blank space, white space, stuff like that we don't want. Can then check our schema just to make sure it reflects what we actually want. Do some typecasting if we need to, all in our Python cells here, and then ultimately write that data set back to a table. So we went from a file in an external stage, did some pre-processing of it, and now have that data persisted in our diamonds table. Now, if I go into the Object Explorer over here, notice I can go into my MLHL DB, go into my schema, tables, and you'll see that diamonds table existed. It was created just now. We can see that it's got about 54,000 rows. You can see the full table definition associated with it, all within the notebook interface here. All right, so we have our data ingested. The next thing that we're going to need to do is look at our second notebook where we will do our data pre-processing to get it ready for model training. All right, so we have our data ingested. Now let's do some pre-processing. To do that, I'm going to go back to my notebooks page here, and I'm going to upload a new notebook from my .ipynb file, and that is that second notebook from our source code repository here. Go ahead and open that up. I'm going to leave the name as is, database and schema or an MLHOL, which is what I want, and then I'm just going to select my MLHOL warehouse, which is what the warehouse I want to use to actually run my code. Click create, just like before. That'll create the notebook and then take us to the notebook UI. Go ahead and close this sidebar just to give us some more space. You'll see again, we've got the same sort of orientation as before. We've got some markdown notebook information on top, the icons and shortcuts on the left, package picker, minimap, all that good stuff. Again, we're going to need to select packages that this notebook needs. So here we see in the markdown cell, we need to pick 3 of them: Snowflake ML Python, Seaborn, and Matplotlib. To do that, I go to the package picker and I'll search for Snowflake ML. Then I'll search for Seaborn and then Matplotlib. Cool. And then you'll see that all 3 of those have been selected along with the corresponding package versions that are available. Then, just like before, I'm going to hit start to connect my notebook to my warehouse. This will take just a few seconds as our warehouse spins up. Let me create the session. All right, cool. So we're active, which means we're good to go. I'm going to go ahead and hit run all just to kick off all these cells, and then I'll walk through kind of step by step what's going on as this runs. So the first thing is, just as before, we need to import our libraries that we need. and then get our session, which is then we're going to make sure is connected. Everything looks right. Yep, we got the user, the role, database, schema, warehouse, using that get active session helper function that I mentioned previously. We just print those outputs and it renders here nicely in the notebook. The next thing we're going to do is specify the table name where we saved our ingested data to, which is that diamonds table. Remember, we can take a look at the Objects Explorer over here, go take a look at our schema tables, and there's our diamonds table. It was created just a few minutes ago. And we're going to use session.table just to reference that table using a Snowpark data frame. SnowparkML has a bunch of data preprocessors that you would typically see from like scikit-learn and packages like that to do distributed scalable computation, fitting transformation of typical preprocessors in an ML pipeline. So, for example, if we wanted to do a min-max scaling on a particular column in our data set, we can import that from SnowparkML. And then reference our min-max scaler, specify our input and output columns, and then call a typical fit transform on our input data set. And you'll see then in our output, we have a normalized caret norm column, which takes this caret field and does a min-max scaler against it. Similarly, we could do ordinal encoding on different columns for color, cut, clarity, things like that have some sort of ordinal relationship. And we import our SnowML ordinal encoder, fit it against our input data set, and then transform it to get our ordinal encoded data. And you can see here then we have for cut from ideal, premium, very good, good, fair, kind of a 0, 1, 2, 3, 4 ordinal encoding. And similar for clarity, I will admit I'm not enough of a diamond expert to explain what each of these categories means, but there's obviously some, kind of a premium to less ideal ranking within these, which is why an ordinal encoder works well. And then we can also see from there, we have then in our output data set, our cut and clarity ordinal encoded fields, in addition to the original fields that you see here. And you might also want to do something like one-hot encoding. We're not actually going to use it for any of our features here because we do have ordinal relationships, which is where you typically might use it. But you can run a one-hot encoder, fit transform, again, where you start to see then the column outputs that you'd associate with. So if you wanted to create a sparse matrix with one-hot encoded values in your categorical data, you could definitely do that. Again, for us, because we're looking at cut and clarity, which are ordinal fields, we're just going to use that ordinal encoder instead. And we can save that whole sequence of steps across cut, clarity, and color as a single preprocessing pipeline object. So you'll see here, we create a preprocessing pipeline, which has the steps of our ordinal encoder and our min-max scaler on our categorical columns and our numerical columns. And then all we're going to do then is basically pickle that file once we fit it locally, fit it against our data, save it, and then upload it to a stage ultimately. So once we have call that fit transform, we can then put that file from our local environment to our stage MLHO assets. And you'll see you'll get the confirmation that happens here. And this is all done locally from the notebook, right? So we can save the file and then upload it to a stage. And then also do things like explore our input data set. So if you want to look at correlation matrices across our features, there's of course SnowparkML correlation function to return that correlation output. And then directly in our notebook, we can use matplotlib, for example, to generate a mask and actually visualize and plot the correlations across our feature set right here in our notebook environment. And so we see things like, carat and price are seemingly positively correlated, which might be a signal for our input features for our model. If we wanted to look at that even a little bit closer, then we could take our Snowpark data frame, bring it into our notebook, and then plot a scatter plot, again, using our typical matplotlib seaborn plotting functions that you have used in Python many, many times before. And you can start to visualize all of this kind of output directly in the notebook itself, rather than having to, move data between different environments or pull data locally to visualize it. it's all done directly in Snowflake with 100% of the code executing in Snowflake directly in the Snowflake Notebook. All right, so now that we have our pre-processing steps built, we can go on to actually training our model, then deploying it for inference once we have a trained model. So I'm going to go back to my notebooks, and then I have already uploaded my third notebook here, which is our model training and inference. Go ahead and select that. Go ahead and close the sidebar there. And the packages I have selected again, once it gets loaded up here, you see I've got Matplotlib and Seaborn and Snowflake ML Python, which is our SnowparkML APIs, already selected. I'm going to go ahead and click Start and connect our notebook to our warehouse, just like before. And you see there, now we're active. Got our markdown for instructions about selecting packages, and then our typical kind of code that we would run through. So I'm going to go ahead and click Run All as I talk through this. You can see over here on the mini map, the green progress bars show the cells that are executing, and the gray blinking ones are the ones that are still queued to be executed. And then we have the solid greens, which are those that have already finished. To get started for our model training, I'm going to import our Snowpark APIs for the data frame objects that we need, as well as our SnowparkML modeling APIs. So we're going to be building an XGBoost regression model here. We're going to show how to do some grid search cost validation using model selection. We're also going to use SnowparkML's model registry to register, log, and deploy our model as well. Along with some other things, obviously our visualization libraries, some metric calculations, things like that. We connect to Snowflake the same as before using that get active session. That creates our session object, which we can then use to run our Snowpark queries or SnowparkML jobs, whatever it may be. I'm going to go ahead and load my data in using session.table, just like before, and then get my pre-processing pipeline, which we saved to that stage previously. Go ahead and load that, and then ultimately use that to create our test and train data set for our regression model. So we're going to use model.fit and model.predict the same way you would if you were running this in Python outside of Snowflake. SnowparkML, however, does all the hard work of translating this to run behind the scenes inside of Snowflake when you run this code, similar to how you would if you were running it somewhere else. So the first thing I'm going to do is do a random split to produce my training and test data sets again from my original diamonds data. I'm then going to run our fit and transform methods from our pipeline object that we just loaded in on both the training set and then our transformation on our test data set so that it's ready to go into our XGBoost model. Then I just initialize an XGBoost regression model and call .fit against my training data set. That runs our model training job, and then I can use regressor.predict on my input data set to start to look at what the output prediction is for that particular model. So we can pass in both pandas data frames as well as Snowpark data frames directly into that predict method. Now, if I wanted to, now that I have a predicted price, I might want to look at something like the mean absolute percentage error on my prediction here. You can see that using the SnowparkML's mean absolute percentage error function, which we imported, we can quickly pass in the input data frame, the actuals, the predicted values, and then get our mean absolute percentage error calculation at 0.07 here. I might also want to look at our actual versus predicted plot itself using Matplotlib or Seaborn. Again, you can do that directly in the notebook interface here. All right. Let's see. The other thing we can do is run our grid search cross-validation. So just like you would in scikit-learn, you might, instead of just fitting a single model, you might actually want to try lots of models and lots of different parameter sets. In the case of XGBoost, that might be our estimator count or the learning rate. SnowparkML does parallelized grid search cross-validation and hyperparameter tuning using the same APIs that you're accustomed to before. So we set our estimator, the param grid, our scoring, input, label, and output columns, and then run our grid search.fit over our training data set. And that produces a whole ensemble of models as well as like a best estimator and metrics associated with each of the parameter sets. So You could, of course, analyze and visualize those results, look at the plot of MAPE against learning rate by the different number of estimator parameters. And we see here that that 500 estimators and a 0.4 learning rate is sort of our low point from a MAPE standpoint. So that might be our best estimator that we want to use. We can see that all from our visualization and everything directly here in the notebook. Now, once I have a result like that, I want to also run its prediction. So I can run, you can see grid search.predict, just like model.predict, and get our MAPE calculation for that best estimator and everything. Look at our actuals versus predicted, just like before, all natively in the notebook. Now, we want to also save this model as well as log some different metrics, tags, metadata against it, so we can create versions, deploy them for inference later, all that kind of stuff. That's what the Snowpark Model Registry allows us to do. It's a native model versioning and deployment framework where we can log our models, tag them with parameters, track metadata, create their versions, execute batch inference, all this kind of stuff directly inside of Snowflake. To do that, all I have to do is run a simple log model statement from my registry where I specify a model name, which in this case we're using Diamond's price prediction, specify a version name for each version. You can use kind of whatever versioning, semantic scheming you like for the model versions. We have some recommendations about how to do this, but you can kind of do it however you like to manage those. Specify the model object and some sample input data, and then set metrics, comments associated with it. So in this case, I want to create my V0 of my model, which is our first iteration. For demo purposes, I also want to create my V1, which was used where we performed hyperparameter optimization. You can see I logged those, kind of using the same type of statement here. All right, so once our models are logged, we can make sure that they're actually there by doing a show versions command like this, where we can see then the metadata for each of those two versions of the models that we created. So our first iteration, the comments, second iteration, some metadata about it, the metrics, things like that associated with the model. You can also, in the case of a model with multiple versions, you can set a default version. In this case, that's our V0 model. We could set that actually if we wanted V1 or V5 or whatever to be our default, we could set that instead. Once we have a model object logged to registry, though, actual inference itself is just a single kind of line of code. So I can use our registry to reference the V1 version of my model, and then simple modelver.run, where I pass in our input data set, as well as the name of the function I want to use. So in this case, you could distinguish between predict versus predict proba or something like that, whatever your predict method might be. Model version.run, and then that creates our output, which is our predicted price right here in our Snowpark data frame. Single line of code directly in the notebook using Snowflake Compute, all that good stuff. Now, one thing that's cool that we haven't touched on yet is also within Snowflake Notebooks, you can intermingle between Python cells and SQL cells. And in particular for model inference, while we have a Python API here to run our models against input data set, there's also a SQL interface to be able to run those models predict methods against input data. And the way that looks is in the notebook here, you see I have just a SQL cell versus as opposed to a Python or a Markdown cell. And then to run my model inference using a SQL statement, in this case just a select statement, I use my model name, Diamond's price prediction, ! Predict. And then I pass in the input columns that basically the input features that model needs to run its predict method. And that creates my prediction output here in my SQL output directly in the notebook again. And I actually could use the output from this cell if I wanted to as a Snowpark data frame to then do other visualization or analysis or whatever it might be. Now this model uses the default version where I just do model name predict, predict. But if I wanted to use a particular model, say that's not the default one, can also add this with clause at the beginning, essentially saying with model version V1 as the version alias. Then I can select, alias ! Predict, just like before, and get my predicted output using the V1 version of my model. Thanks for following along. Today we showed you how to use Snowflake's notebooks to run end-to-end SnowparkML workloads to build and deploy machine learning models all directly inside of Snowflake. We hope you enjoyed the video. If you'd like to see more content like this, make sure to like and subscribe down below to the Snowflake Developers YouTube channel, We're putting out a playlist of notebook demos like this to kind of show you how to perform common tasks for data analysis, machine learning, data science, data engineering, all using Snowflake's new notebooks. So make sure to keep a lookout for that. And I hope you enjoyed the video, and we'll see you next time.